we'll look at how a function and its inverse relate graphically. So I have a figure on the screen that shows the graph of the functions, which are inverse functions. The function f, which equals x minus 4, all divided by 5, and the function g, which equals 5x plus 4. So notice that on the graph of the function f, we have the points 1, negative 4/5, and 4, 0. And then on the graph of g, we have the points negative 4/5, 1, and 0, 4. We've talked about this before, that if the point AB is on the graph of f, then the point BA is on the graph of the inverse function. The graph of a function and its inverse have a really unique property, and that is that the graph of a function and its inverse function are symmetric about the line y equals x. Remember that y equals x is that basic linear function. It has a y-intercept at the origin. The slope is 1, so it goes up 1 over 1, which means it goes through the points 1, 1, 2, 2, 3, 3, and so on. So on this graph with our function f and g that we just saw earlier, that was f is x minus 4 divided by 5, and g is 5x plus 4. I also have this line y equals x as a dotted line through the graph, and I see that if that point AB is on the graph of f, then the point BA is on the graph of g, or its inverse function. So we can also notice that if we fold the graphs along that diagonal, right, that line y equals x, we'll get a mirror image of itself. We will have some problems where we want to sketch the graph of the inverse of each graphed function. In this example, I have the graph of a line that goes through the points negative 2, 0, and through 0, negative 3. On the inverse function then, I need to reverse the order, right? If AB is on the graph of f, then BA is on the graph of the inverse. Therefore, negative 2, 0 would have a point 0, negative 2 on the inverse. 0, negative 3, when I interchange those x and y values, it would be negative 3, 0. So if I draw this line that connects those 2 points, I would get the graph of the inverse function. And so I see this line, and if I draw the line, say dotted line, this line y equals x, I see that the two graphs are symmetric about that line y equals x. Now I have this half parabola that goes through the points negative 3, negative 2, goes through the point negative 2, negative 1, and also goes through the point 1, 0. So on the inverse, I need to have the point negative 2, negative 3. So negative 2, negative 3. Then I need to have the point negative 1, negative 2. Instead of 1, 0, I will have the point 0, 1. And so now I can draw this half parabola that goes up from negative 2, negative 3, through negative 1, negative 2, and continues through 0, 1, and on up. And again, if I have the graph and I draw through this line y equals x, I see that my graph is symmetric about that line.